Hello and welcome back to Math with Mrs. Becker. Today in Precalculus, we are going to be graphing piecewise functions. This is the second part of Chapter 3, Section 2. Just as a reminder, a piecewise function means that you do have a function with separate pieces. Now, in order to figure out which piece to use, you need to look at the domain. So if your x value is less than or equal to 0, you would use the piece 2x minus 3. But if your x's are larger than 0, you would use the quadratic x squared minus 1. So the first thing that we want to do is graph. If we are graphing a piecewise function, you will need an xy table for each piece. So in this case, because we have two pieces, I will need two xy tables. First, let's start off with 2x minus 3. Now, when I'm graphing this, I can only use x values that are less than or equal to 0. It's very important that I do include this endpoint. So 0 needs to be in the xy table. The 0 is included, so when I graph it, it will be a filled-in circle. Now my other values have to be less than 0. So if I go -1, -2, when I graph this pattern continues to the left. So I will have an arrow heading to the left, okay? Now let's just go ahead and do the xy table. If I put a 0 in, 2 times 0 minus 3, 2 times 0 is 0, 0 minus 3 is -3. If I fill in the -1, 2 times -1 is -2, -2 minus 3 is -5. Last but not least, let's fill in that -2. 2 times -2 is -4. -4 minus 3 is -7. So now I can go ahead and graph that piece. So 0 down 3, it's a filled-in circle because it's included. Your 0 value is included with the top. Left 1 down 5. Left 2 down 7. It's off the graph, but that's okay. Now this pattern continues. It's less than, so I will have an arrow going to the left. Now when I do the other piece, again, I have to start with, this is basically the starting point. So I do have to include this 0. What is mentioned in the domain needs to be in your xy table. 0 is technically your starting spot. However, it's not included. It says x is greater than 0, so at this location, I have to put an open circle. Then other values for x, I will say 1 and 2. Now this is going to be a portion of a parabola because this is quadratic. If I go 0 squared minus 1, 0 squared is 0, 0 minus 1 is -1. 1 squared minus 1. Well, 1 squared is 1, 1 minus 1 is 0. 2 squared minus 1. 2 squared is 4. 4 minus 1 is 3. So now when I graph this, I will have an arrow going to the right because x is greater than 0. So this piece of the function will continue for all of the values that are greater than 0, meaning going to the right. So if I go 0, -1, that's an open circle. 1, 0, and 2, 1, 2, 3. Again, notice it's curve shaped. That is a parabola, and we have an arrow. So what you just did is you graphed a piecewise function. Kind of cool. Now the domain. Typically for the domain, I like to look up here and just kind of sketch. Your domain means which x values can you use? Which x values can you put into xy tables and you'll find a value? Well, this says I can go 0, include it, and go anything to the left. And this says starting at 0, I can go anything to the right. So notice it includes everything. There are no spaces, no values that are not included. So your domain is all reals. Or you could go -infinity to infinity, because I know some of you are really liking that interval notation. Okay, your range. Your range, we have to look at the graph and go bottom to top. Now notice there are two separate ranges here because we have this space in the middle. We have an opening in the range. These values are not defined for y. So this piece is y is less than, because it's going downwards, or equal to -1, -2, -3. Or, now it starts here, y is greater than -1. It's not included because it's an open circle, but it goes upwards. So the domain, we can have all real numbers. If you notice, this includes the left. We go to here, this is open, but this is filled in, and this continues to the right. So all of the x's are used, but there is a space in the y. Now they want me to go ahead and evaluate. Remember, when you're evaluating, it's important to realize that this 3 is only going to fit into one of the pieces. The 0 is only going to fit into one of the pieces. Same with the -2. So you have to look and say, okay, which one do I use? If my x value is a 3, 3 is larger than 0, so it goes into the second piece. 3 squared minus 1. 3 squared is 9. 9 minus 1 is 8. If I do f of 0. Now 0 is mentioned in both domains, but it's included in the top piece. So I need to go 2 times 0 minus 3. 2 times 0 is 0. 0 minus 3 is -3. And last but not least, f of -2. Now -2 is less than 0. So I need to put it into the top piece. 2 times -2 minus 3. 2 times -2 is -4. -4 minus 3 is -7. So that is one question. You will be graphing the piecewise function by creating XY tables. Looking for the domain and the range. Remember, domain are the x values, range are the y values. Then you'll be doing some evaluations. Okay, let's do another one. Now this time, right away, if you look at g of x, I see that yes, this is a piecewise function, okay, because there are separate pieces. But this time, notice that there are 3 pieces. So what that means is in order to get the visual, I need 3 XY tables. You need a separate XY table for each piece. So when I go ahead and do the top, my XY table needs to start at -1. You have to include this value. Then you look to see if I'll have an open or a closed circle here. This -1 is not included, so it's an open circle. The other values for my XY table have to be less than, because x is less than -1, so smaller values would be like -2, -3. If I go 3 minus -1, minus a negative, we're actually adding, so it's 4. 3 minus -2, again, minus a negative, we're actually adding, 3 plus 2 is 5. 3 minus -3, minus a negative changes to plus, 3 plus 3 is 6. X is less than, so this piece continues to the left, so I'll have an arrow going left. -1 up 1, 2, 3, 4, open circle. -2 up 1, 2, 3, 4, 5. -3, 1, 2, 3, up 1, 2, 3, 4, 5, 6. It's off the graph a little bit. Less than, so this will continue to the left. There's that piece. Now the next piece. This is bounded, is what it's called. It has a starting point and an ending point. So I will have no arrows here. I go -1, 0, 1. The -1 is included, so it will be a filled in circle. The 1 is included, so again, it will have a filled in circle. But there are no arrows because this pattern doesn't continue. It starts here and ends here. This is a constant. A constant is just a number. It results in a horizontal line. So what that means is for any x value -1 to 1, your y value is going to be the constant 2. So this is what this will look like. Left 1 up 2, filled in circle. Stay at 0, 2, right 1, 2, filled in circle, done. No arrows because it does not continue in either direction. Starts at -1, ends at +1, done. Last piece. You have to include the 1 in your XY table. Okay, this is technically the starting point. It's not included, so it's an open circle. My other values need to be greater than 1. So I'll go 2 and 3. 4 times 1 minus 1. Well, 4 times 1 is 4. 4 minus 1 is 3. 4 times 2 minus 1. 4 times 2 is 8. 8 minus 1 is 7. 4 times 3 minus 1. 4 times 3 is 12. 12 minus 1 is 11. Now this will continue to the right because it's x is greater than. So it will continue to the larger x values, meaning going to the right. If I go right 1, up 1, 2, 3, open circle. 2, up 1, 2, 3, 4, 5, 6, 7. At this point, I'm already off the graph. I know this is a line because I have a single x, so I'm just going to go ahead and connect it. From geometry, we learned that you only need 2 points to form a line. So here, though, I can see that it's pretty darn steep. So here is your graph. That's kind of cool. Your domain. If I go ahead and I look at all these pieces, the top piece says -1. Anything to the left of -1 is fine. This says -1 to 1 is fine. This says anything to the right of 1. So notice when I go ahead and look at these different descriptions on a number line, all x values, all real numbers are included because you can go to the left forever, you can go to the right forever. Our endpoints, you can go in between them, they're included. So your domain is all real numbers. Now your range, looking bottom to top, I do have y equals 2. That's that horizontal line. Now here, I do see that I can say y is greater than, it's an open circle, 1, 2, 3. And that would actually include this piece as well because it would start here. This piece falls within that range. So your range is y equals 2 to get that little horizontal line. Then your y values start at 3 and go upwards, but it does not include the 3. Last but not least, we need to go ahead and evaluate. So if I have g of -5, we need to look here and say, okay, where does -5 fit? -5 is less than -1, so I need to fill it into the top piece. 3 minus -5, if you minus a negative, it becomes a plus, so that ends up being 8. G of 1. Well, these two pieces both mention the 1, so you have to see where is it included. It's included in the second piece. Any value -1 to 1 has a constant, meaning it's always going to equal 2. G of 3. 3 is larger than 1, so it goes into this piece. 4 times 3 minus 1. 4 times 3 is 12. 12 minus 1 is 11. So there's a second example. I have 2 more for you just to make sure that we've got this. Okay, now this time, notice this is quadratic, so it's part of a parabola. This is quadratic, so it's part of a parabola. I do only have 2 pieces. If you have 2 pieces in your piecewise function, you need to have 2 xy tables. This says that we start at 1. X is greater than 1, so the 1 is not included. It's an open circle. Your x values from or for your table have to be larger than 1. So I'll go 2 and 3. This pattern continues. It starts at 1 and it's greater than, x is greater than, so I'll have an arrow going to the right. So -1 squared plus 5. Order of operations, we have to do the exponent first. 1 squared is 1. 1 times negative is -1. -1 plus 5 is 4. Now I go ahead and I fill in a 2. 2 squared is 4. 4 times -1 is -4. -4 plus 5 is 1. Next, fill in a 3. 3 squared is 9. 9 times a -1 is -9. Plus 5 is -4. So let's go ahead and graph this. Again, I know it's going to be a portion of a parabola because it is a quadratic function. It has a degree of 2. Go to the right 1, up 1, 2, 3, 4. That's an open circle. Go to the right 2, up 1. Go to the right 1, 2, 3, down 1, 2, 3, 4. And I have an arrow to the right because its x is greater than. That just means that it continues on the x-axis to the positive direction, which is the right. Okay, now if I go to the next one, again, my domain, I start at 1. This time it is included, so it's a filled-in circle. My x values have to be less than 1. So I'll go 0 and -1. If I have 1 squared minus 3 times 1 plus 2. If I fill all that in, I end up with a 0. If I go 0 squared minus 3 times 0 plus 2, well, we get a 2. If I put in a -1, -1 squared minus 3 times -1 plus 2, when you go ahead and calculate that, you will get a 6. I will have an arrow going to the left side because x is less than 1. So this piece continues to the left. Go to the right one, stay at 0, 0, up 2, -1, up 1, 2, 3, 4, 5, 6. It's off the graph. When I connect them, I do realize that, yes, this is part of a parabola, which is awesome, okay? Now the domain. If I start at 1, I can go all the way to the right. This includes 1, goes all the way to the left. All of the x values are included. So remember, that's the symbol for all real numbers, okay? Your range. Look at this. There are no spaces. So like where this stops, this value does have a y. So if I go bottom to top, every single y value is included through either this piece or this piece. So the range is also all real numbers. Now what I need to do is go ahead and evaluate f of 0. 0 is less than 1. So if I go 0 squared minus 3 times 0 plus 2, I get a 2. If I have f of -2, -2 is less than 1. So it's -2 squared minus 3 times -2 plus 2. I'm just filling it into the second equation. When you go ahead and calculate that, you would get a 12. And f of 5. 5 is greater than 1, so it's -5 squared plus 5. 5 squared is 25. 25 times a negative is -25. Plus 5 is a -20. Okay, last thing that we are going to graph. This type of piecewise function is called a step function. And it's really, really cool because at the end it looks like stairs. Notice that these are all constants. And when you have a constant, the result is going to be a horizontal line. So if I go ahead and make XY tables, I would need 1, 2, 3, 4, 5 of them, but that's okay. We got this. 1, 2, 3, 4, 5. Okay, the first piece starts at -5 and ends at 3, so there's no arrows because it starts here and it ends here. So -5, -4, -3. The -5 is included. The -3 is not. At these x values, the y is a constant 6. So I go to the left, 1, 2, 3, 4, 5, up, 1, 2, 3, 4, 5, 6. This is a filled in circle. This is an open circle. That is this piece. Check. Now the next one, -3, -2, -1. Again, no arrows because it starts at -3, it ends at -1. The -3 is filled in, the -1 is not. For these x values, the y is a constant 3. So to the left, 1, 2, 3, up, 1, 2, 3. That's filled in. That's just a point, open circle, connected, check. -1, 0, 1. No arrows, starts here, ends here. The -1 is included, the 1 is not. The y is a constant value of 0. So left 1, 0 is filled in. Here's a point, here's an open circle, done. Starting at 1, ending at 3. So 1, 2, 3. The 1 is filled in, the 3 is open, the y is -3. Again, no arrows. If I go right one down, 1, 2, 3, that's my filled in circle. There's a point, there's an open circle, check. Last one, I start at 3, end at 5. The 3 is included, the 5 is not included. The y value is a constant -6. Go to the right, 1, 2, 3. Down 1, 2, 3, 4, 5, 6. Filled in circle. There's a point, there's an open circle. So this is called a step function because if you visualize a little dude, he can go doink, 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 and he can like hop right down the steps. It's like a video game. All right, guys, that's graphing piecewise functions and also reviewing how do you evaluate piecewise functions. Your assignment for the day is a worksheet. Hope you had a great time. Talk to you soon.